Good morning, good afternoon, everyone. My name is Chris Doran. I am a technical sales specialist for ITM Instruments. Thank you for joining us for our webinar today via ITM University. Today's topic will be covering Introduction to Acoustic Sound Imaging with Fluke. We kindly ask you throughout the presentation to mute yourselves and mute your microphone. Our presentation will last about 40 to 45 minutes, and we'll have a designated time for Q&A at the end of the presentation. Throughout, we do encourage you to ask questions at any time using the chat feature, and we'll get to them, like I said, at the end of the presentation. If there is something really pertaining to the immediate slide, don't worry. Our presenter and I can refer back to that slide when that question comes up. So at ITM Instruments has been working closely with Fluke for many years. We pride ourselves on being a leading distributor for Fluke electronics. This is a result of our dedication to offering you our product expertise, service, and competitive pricing. Getting started today, today's webinar will be presented by Ken Reeves from Fluke. Ken is Fluke's territory sales rep based in Alberta, Canada. He has over 31 years of technical test equipment sales, including 20 years working with Fluke directly. Ken, presentation for you.
Thank you, Chris. Good day to everybody. Today, we'd like to talk to you about a couple of new products. One is the Fluke ii910, and the other is the Fluke ii900. Let's see if I can get it to change screens for me here. There we go. They are two new products. They're in a brand new class of products. The technology is what we're calling sonic industrial imaging or acoustical imaging. And these are the first two industrial cameras that feature Fluke's new sound map technology. So let's quickly get into it. There's a few agenda of the items that we'll cover off today. Generally, we want to give you an overall view of what is acoustical imaging. Have a quick review of the features of the ii900 and how it compares to other existing technologies, and maybe get into some of the cost-saving opportunities that you'll have by deploying a sonic industrial imager at your location. We'll review some best practices on how to make this potentially a really valuable product in your toolbox, and then we'll introduce the new ii910 to you, which is a version of this product that we just launched probably about a month or two ago, and has more features and functions to it. And without any further ado, we will move forwards here. So what is acoustical imaging? Some people will look at this image and think it looks like a thermal image, but it's similar in the sense that we take information, similar like information from a sound perspective, and overlay it on top of a visible light image. So what we do is we take sound from the human audible range all the way through to the ultrasonic range. The ii900 will get us up to 50,000 kilohertz, 50,000 hertz, and it gives us the ability to measure the sound energy in an array and determine where the sound is coming from and overlay the intensity of that sound on a visible light image. The sound map is what we call the array of information, and sound sight is when we lay it on top of visible imaging. So ultrasonic technology has been around for a long time. There's been a lot of different types of ultrasound. If you have ever had an injury, there's ultrasound tools that will be able to look in you. There's ultrasonic cleaning, ultrasonic level measurement in industrial applications. And what we're focused on today is actually the ultrasound that was used for measuring leaks. These are typically handheld devices, and they have specific measurement capabilities that allow them to hear ultrasound being created by the turbulence coming out of a leak. So leak detection before the ii900 involved a couple of different methods. First, you would have to use a handheld device that had either parabolic curve. You'd use a set of headphones like the image over here on the side. This is actually a gentleman by the name of Chris Cassidy. He's an astronaut from NASA, and he was using an ultrasound detector to listen for the ultrasound of a vacuum leak from the space station. But you can use soapy water. All of these different types of technologies can be used to find a leak. The problem is that a lot of ultrasonic equipment is hard to find. The equipment in the past was hard to use from a distance. There was typically training required to make sure you're optimizing how to get it to work for you. If you weren't close, you had to get scaffolding and PPE and whatnot to wear to get yourself in that safe environment. It was very time consuming. So what wound up happening was only the critical jobs were being done, and leaks were considered to be not worth the effort. And people just ignored leaks and just considered it to be a part of just doing business. By introducing the ii900, we were able to improve the way that people do their scanning. So this is an example of the way it would have been done before. The person on the left, lower left corner in that image is using a handheld device with a parabolic microphone. The parabolic part of it is clear. It's hard to see in that image, but they would scan in a wide area using a set of headphones and trying to control some levels and frequency ranges manually on knobs and dials and whatnot. And it would take quite a while to scan and try to find this information. If they did determine that there might be a leak in a certain location, they would change over the probe and then make a unique measurement right at the particular point. Again, if it's hard to reach, they'd be on scaffolding and whatnot. Once they did all that work, they would go and do a tag and identify it for potential or future repair. The problem with all of this is it was just way too time tedious. So we went and saw a customer and we said, okay, show us how you use this. And this is just an example of what they did. And they found one leak in about 20 minutes and manually tagged it and documented it and showed us the process. So we showed them the ii900 and we described how we would do it. And basically what we did is we had him hold it and he reviewed from a distance, and he was able to scan the same area much faster, finding multiple leaks at the same time. So there was no hunting, there's multiple leaks on the display, and he was able to, scan, pinpoint, and in this particular case, he was able to identify that there was a leak close to that compressor system, walked over and actually found two leaks side by side that are initially presented as one. So the fact that we can find things faster is a major advantage. And what it actually does is it changes the game and changes the way that people will consider looking at ultrasound and leaks in particular. So let's talk about how the ii900 actually does this work. So using that sound map and sound sight technology, we take a look at the way the ii900 looks. In your hands, it has a 7-inch display that is touchscreen, so you can touch it and move the menus around. Very simple to operate. It has an on-off button, and the button on the side, it allows you to save images and save video as well. So it's very simple to use, and there's no training involved at all. On the other side, when you turn it around, you'll see where the microphone array is. We have 64 high sensitivity acoustical microphones set up in a specific array to be able to make measurements. Technically, what's going on is we're measuring very high frequency events, and we are correlating them from a triangulation point of view and finding out where those energy events are coming from and how strong they are. And we're laying them on top of the visible light camera image. So there's actually a lot of technology happening in the background, even though the box itself seems quite simple. Initially, when we launched the ii900, we decided to focus specifically on compressed air leaks, vacuums, and leaks from other gases. The interesting thing is that the customers have taken that product and gone out and found many, many more applications. And it kind of drives the discussion we're going to have shortly here on the ii910. So let's talk about compressed air leaks specifically and get an idea what the financial implications, or you may consider it return on investment or ROI, might be. So we've categorized them into 5 different groups. The first is a capital cost. If you were having leaks happen in your system, it would cause your capital equipment, the actual compressors that you have, to wear out faster because they're running more than they need to. And obviously, when they run more than they need to, they will wear out and need to be replaced sooner. From a product quality point of view, if you're making product that depends on good air pressure, Having a leak or not having enough volume of air available to you because your compressors are leaking and not getting the air to your tools might result in lost productivity, bad product, and it can be very, very expensive if you have to find ways, especially if you're considering adding another compressor just to keep up to your load. The energy costs, this is something that is interesting. The electrical energy that typically runs compressors is at best 7-to-1 ratio in terms of energy efficiency. So for every leak that you have, you're wasting 7 times that much electrical energy. It gets to the point that that leak is continuous, and therefore the electrical energy loss is continuous. The next slide will discuss this in a bit more detail for us. The cost of gases, what we mean by that is air is, for all intents and purposes, doesn't cost us a lot of money. There may be some drying equipment that would be consumable in the front end of that to make sure that the air is good quality for your tools. But if you are buying other gases, or you have other gases that are being either compressed or delivered through systems that are pressurized, having those leaks happen can be very expensive because you've already paid for that gas. And any contracting that you have to make that gas less expensive will just literally leak away on you. From a manpower point of view, the biggest problem in the past was leaks were difficult to find, and then repairs had to be put in place, and then you had to test afterwards to make sure that the repairs were effective. And it wound up taking a lot of time in that process. And what wound up happening was customers considered any leaks that they had just to be a cost of doing business, and they didn't pay attention to them. So this new technology really changes that game because we can find leaks faster. You put in the same repair, and then we can prove that the leaks were repaired quicker than ever before. So I mentioned that the next slide would have some information on a particular energy application. This company is, some of you may be familiar with it, but they do lifting equipment. They manufacture that equipment. So they have a lot of air tools for painting, for welding, for tightening and whatnot at their manufacturing location. And they had 4 compressors running, and they used a Fluke power quality analyzer to data log the energy that was being used on those 4 compressors over a 7-day period. They used an ii900, went out and found the leaks, made the repairs, and did the test afterwards using that same energy logger. And you notice on the bottom here, it says that they found 25% savings on their energy to those compressors, which, doing the math based on a year and what they pay for their electricity, resulted in around $50,000 worth of savings that they recovered annually. So significant savings, and for all intents and purposes, it didn't take much effort to get to that point on their side. So do you need an ii900? It's a question that we try to focus on and make sure that we're delivering what you need to do your job. So if you find on the side here, if you're the company you work for or the business that you're involved with is involved in any of that, be it discrete manufacturing or process manufacturing, oil and gas, or even others where there's compressed air, you may be a good candidate for considering an ii900 in your system. The actual advantages are well documented, and what we look at, and from a sales perspective, what we look for is companies that have large compression systems, people that are contracting their inspection services, perhaps maintenance teams that are already involved in looking at compressed air, and or service providers offering leak inspections. There we go. So let's have a quick discussion about the ii900 and how it actually works. So this is an example of a display of an ii900. What I want to point out to you is a couple of things that they've highlighted in this slide. First of all, on the right-hand side is the frequency spectrum that the ii900 runs from. So it runs from just under 5 kilohertz, where we normally hear audio, all the way up to 50,000 hertz, where we would not hear audio. Depending on how old you are and how well your ears work, most people's ability to hear stops at around 20,000 hertz. What we do is we listen to a wider spectrum into the ultrasonic range, and we lay that out on the sidebar, and then we give you the opportunity to adjust what's in the yellow section, which is the filtering. So it allows us to filter in on specific frequencies that the leaks may be happening at. We provide the dB scale, which is the energy of the sound, and it shows up as a color palette that will be overlaid on top of the visible image. The center reading can be turned off or on, and that's just an indication of the actual sound energy at that point. We have date and battery and time information. And then on the left-hand side is where you have all the menus. The menus run from our our touchscreen display, and we can dive into those different menus and show them to you independently on the next set of slides. So one of the first menus we have at the top left was the image menu. This slide is actually from the very first launch of the ii900. So it showed that we do images and video. There's actually another option available on the ii900 that shows something called Leak Q that I will get to in a moment. But on the image side, we have the ability to capture what we see on the display as an image. It can come across as a JPEG or a PNG file. And then on the video side, we can capture a stream of video as an MP4. Once you have that information loaded and saved into the device, we have the ability to take a look at the memory files, and you can go back and review what you've taken and pull them up and see them again on the display and review them at that point. Further down the menu, there was a button there for palette. The palette is just a word that we use to describe the colors that we are laying on top from the sound map onto create the sight sound. The red-blue is not recommended because of some colorblind issues. If you're colorblind, the coloring may not make sense to you. So we typically use gray or what we call iron bow, which is very familiar on the thermal imaging side of things. Markers, we have the ability to turn that center point marker off and on. So some practical considerations. This part here we'll talk about how to use the device. And if you're having any questions on what we just came through, please type them in the chat menu so Chris can address this at the end. Practical considerations, let's talk about kind of best practices on how to use the ii900 most effectively. So I mentioned earlier the filtering capabilities. We highlighted that filtering capability in green right now on the display, and that allows us to filter out every other frequency above or below that box. So it removes interference from other background noises. We have a lot of customers who say, oh, I'm in a very noisy environment. How are we going to hear a little tiny leak? It's actually very, very easy when we filter out exactly what we're looking for. The indications on the sidebar here that are the yellow bumps, those are just graphical indications. They're not real. But when we get to some other images, you'll start to see some real things that have some very noisy environments when we take a look at some application pictures at the end of the slide deck. So you pick the appropriate frequency, you maximize and find out what your leak is, and you have that ability to do that very quickly and easily with the touchscreen. So I'm going to run a quick little video for you, but this is something that we need to consider. Reflections can be something specifically with high frequency has a tendency to bounce around off of hard surfaces. So we need to keep this in mind when we actually do a scan as a part of our best practices considering. So I'm going to run the video for you now, and you'll notice what appears to be a leak in perhaps, and if you take a look at the image, it's like a welding cable. But when we run the video, we notice that the leak is moving. So part of the best practices is if you see something, one of the things you want to do is just find a safe way to make a move and see if it moves, then there's a good chance you're not looking at the actual source. In this case, it moved onto the floor, and it was actually a reflection from a leaking air fitting from underneath the table. So let's talk about some of the key performance of the ii900, kind of the data sheet or specs it has. So I mentioned earlier it has a 7-inch capacitive touch LCD display. The really cool thing is that we can detect leaks from as far away as 50 meters. We can save up to 1,000 images on the device. Again, I mentioned JPEG or PNG files. And on the video side, it'll record up to 5 minutes of fully blended video that's available to you at the end as an MP4 file. Battery life, it comes with 2 batteries. Each battery will last about 6 hours, and in the charging base, it will recharge in 3 hours. So theoretically, you'll never be without a charge if you keep your batteries swapping out of the charging base. So we've been talking about compressed air, but it also works extremely well on vacuums, steam, and other gases. And I mentioned leak Q mode. So back about 6 months after we launched the product in April of 2019, we launched a new free firmware upgrade. that allowed us to activate leak Q mode. Now, what leak Q mode is a specific function that allows us to take a look at the leaks that we see, and we turn on leak Q mode and we generate this circle on the display. Within that circle, we measure the distance to the leak and provide a severity scale from 0 to 10, 10 being the worst and 0 being no leak at all for the most part. We take this information and save it as a leak Q file in the ii900. It shows up as what we call an AS2 file format, and you can convert that file, take that file format from your computer and upload it to a free tool online at the Fluke website, and answering a few questions about what the pressure is, what the actual gas is that you're measuring. We can come back and calculate the actual cost of that leak every year. This is used primarily for prioritization of your leaks. So you may have 20, 30 leaks that you've captured this way. It might be nice to know which one is the biggest one because you only have time to fix 2 or 3 today. So that's the analogy, and that's what can go on and help you prioritize where your leaks are coming from. So let's talk about some things that we don't do with the ii900. So refrigerant leaks, we get asked this question occasionally. The problem with refrigerant, it's a closed system, and when a leak happens, it usually doesn't last very long. And even if it did, there wouldn't be enough volume to create the sound that we need to be able to hear it. So we defer to this one as something we won't do. We recommend that you use a leak detection sniffer and actually try to sniff out the actual gases that are coming out of your refrigeration system. Partial discharge is another application. This is actually one that the customers were quickly finding that they could do with the ii900, but we weren't fully ready to support the application because it requires higher frequency than 50 kilohertz. So we can see some, as you can see on that image, we're seeing some partial discharge happening at 4.6 feet away, and determining that we can actually see it. But we can't see all of them, so we're a little bit hesitant to support the partial discharge on the ii900. What we do recommend is that you consider the brand new ii910. It has 2 extended feature capabilities. One is that it goes to 100 kilohertz now, and it also has more sensitive microphones for leaks on the low end. So we will be able to pick up all kinds of partial discharge. So this groundbreaking technology, it's the same image, same device, but this is the 2 technologies. We have the ability to do partial discharge, and on the right, it shows visual leak detection with more precision. So let's talk quickly about partial discharge. If you're not familiar with the concept of partial discharge, I'll try to encapsulate it here. Partial discharge is when typically high voltage electrical energy doesn't necessarily completely short, but it begins to short, or it starts to trace or track across surfaces or just into the air. What winds up happening is, if it's happening into the air, there's an ionization of the air around it. And typically people that were looking for corona would have spent significant money on a UV-IR corona camera and tried to capture those images. That's the image on the top right, where they got a little pink spot happening at the top of that conductor. That's an idea of what happens when you have a leak, a PD situation happening. We can see the same PD from a high frequency ultrasound point of view, and it gives us the ability to find perhaps even multiple leaks at the same, multiple PD situations at the same time. I did want to bring your attention to the little graphic in the bottom right-hand corner. So it's really hard to see even on my large display, but the concept is, as we start on the left-hand side, and then as the PD situation gets worse, it has a tendency to drop down in frequency. And you notice that the cost also has a tendency to go up in terms of what it takes to repair. This is not a Fluke graphic, this is from somebody else, but the idea is that having the higher frequency in the ii910 allows us to find the problem sooner, when the repair might be way less expensive than having it become very expensive and fail on us. So let's talk about, there's 4 different types of partial discharge. The corona discharge is where it discharges electrical energy into the air and creates ionization. We can see that, no problems. Surface discharge, as shown on that image there, is where you see tracking across the surface between two conductors or between what should be insulating material. And we can see that with the ii910, again, no problem. Arcing, that's a pretty obvious one, but we can see it as well. The one that catches most attention is voids or internal discharges. Typically, it's pretty difficult even for a UV IR camera, can't see it because there's no ionization getting out. So they typically use very expensive electrical measurement tools. We can see some of this. It has to do with how deep under the surface it is. So conductors and splices that are a couple inches thick, we can see them. We actually have some video and some images of finding these before they turn into problems. So it is something that we're hesitant to say we can completely do, but you may find that you have that ability with the ii910 because it is so sensitive. From a money point of view, obviously, if you are at all aware of PD, you can understand how expensive it is. It's typically happens where there's high energy, and high energy is usually where it comes into a plant or a substation, or if you're utility, a transmission line. And when it fails at those points, you're talking about downtime for lots of different customers if you're a utility, or quite a large part of your plant, or maybe even the whole plant if it happens to you personally. So it's very expensive. There's a lot of damage that happens typically when it fails because it creates an arc flash, which is very, very destructive. Some specialized equipment has to be rebought quickly, or temporary solutions have to be put in place. So finding and detecting PD is critical. So let's talk beyond PD and discuss the visual leak detection side of it on the high sensitivity and low leaks. So typically in the past, people would ask us, what can the ii900 see? And we were able to see, these images are from an ii900, not an ii910, but that's a bellows system that's running at 15 PSI. And we can see the leak happening on that. So the natural gas line there is, again, typical low pressure and a very low density gas. And we can still see leaks happening there. The ii910 will be able to see these and even lower. So we're waiting for some detailed specifications to support what we're claiming. But as of right now, we're generally saying we're twice as sensitive as the old ii900, which I said old, but it's still available. So on the leak side of things, detecting leaks quickly and being able to fix them, we've discussed that already. And the return on investment is similar. We just add an extra layer of capability on the lower end in terms of finding leaks either sooner or lower leaks that are maybe potentially more expensive because it's a compressed air leak or compressed gases that we're paying for. So this is the ii910, and it's a discussion that we want to just have a quick discussion here about the features and why it might be different. So it says on the display on the left-hand side, it says leak Q and PD mode. So this PDQ mode is similar to leak Q, and it allows us to capture the PD events from a PD count point of view, which I understand other companies have been doing for a while, and we can measure the distance to that PD event. We can do video recording again for 5 minutes. The sound map image is the same. The thing I wanted to highlight here is that the higher frequency, 100 kilohertz, and we don't lose any of our IP rating. And the other one is that the distance is extended on the ii910 to 120 meters, which is just over double what the ii900 did at 50 meters. And here's a comparison happening side by side between the two. And I'll run through some application information here for you, just so you can see where we've had success, and we'll discuss them a little bit more detail. And then after that, we'll be open to questions. So first of all, these are some compressed airdrops that in a particular location. The side image over here on the right-hand side for the actual sound that we're measuring, these are, again, live images or real images. So you see it was quite noisy in that environment, but we were still able to focus in and find a frequency event happening at those compressed airdrops. At the same location, we were able to see leaks at a compressor connection. Air regulators, another good example. All these little leaks add up. This is a production line at a food and beverage facility. This particular company you may be familiar with. I know it's moving by quickly, but based on the red, you might know who we're talking about. But what I want to point out here is how much noise there was in this environment. These facilities are very noisy, and the fact that we were able to pinpoint one little tiny leak down underneath and help them get that under control was pretty amazing in terms of what the technology can handle. Again, just walk in and point it and take a look. This is a leak on a nitrogen system. Again, nitrogen is a gas that you're going to be paying for. Same thing with ammonia. You're going to pay for ammonia, and there's also a big health safety concern with ammonia leaks. Most systems that are running ammonia have alarming systems, but ammonia is a very deadly gas. Argon, if you have any welding facilities, it's good to check out your argon systems. You notice the little patch below, that's a reflection. So because it was so close to that actual surface, we were able to see both at the same time. Wouldn't necessarily suggest somebody's going to buy an ii900 for doing just airlines on semi-trailers, but it has that ability. Again, air leakage is easy to find. I was out showing this to one customer, and he had picked up a flat tire earlier that day, and we went out and showed the ii900, and he's like, "Come see if I can see my flat." And we saw clearly where the leak was coming from, and it was a little tiny pinhole. There was no longer a nail or anything in there, but he saw exactly where it was. It was kind of fun. So we talked about vacuums. Duct leaks on a coal plant is a great example of what we do with vacuums. The turbulent air that gets pulled through into the vacuum, it generates the high frequency, and we can find it very quickly. One of the very first ii900s we sold in Canada went to a potash mine in Saskatchewan, and they had a vacuum leak system. The only way they knew there was a leak was the vacuum gauge would drop off in terms of what it saw for vacuum. And the other part of the problem was it directly created issues with their production productivity and product quality. By putting the ii900 in service, they were able to find 3 leaks in like literally 2 minutes, where before it was taking them somewhere in the order of an hour to find these leaks in all the piping systems they had. So it was literally a game changer for them. We talked already about partial discharge. Again, this is from an ii900 image, but the ii910 would have been able to see this particular event happening perhaps even earlier than we found it here. And again, natural gas lines, the same image as we used earlier. So I'm going to move to the next screen. That's the end of the presentation in terms of products and information and technology. I'm going to leave this screen up, and if you have any questions, please put them in the text message, and I'll let Chris handle it from here.
Thank you very much, Ken. Thank you for the extremely informative presentation. Everyone connected got as much out of it as I did. So as Ken just said, if you do have any questions, please use the chat feature. We have plenty of time available to get to any and all questions that you have. So please take this opportunity that we have a product expert and this type of application expert connected with us to ask any and all questions that you have. We did have a few come in throughout the presentation. Mike asked, how do we know what frequency to set the camera to?
That's a great question. It has to do with kind of a best practices that we didn't cover off in the slide deck. What we suggest you do is set the filter fairly high, but also fairly wide. So if you keep it above the audible range, you may get some flickering and flashing. And what we suggest you do at that point in time is raise the lower level until the flickering and flashing begins to go away, and then bring down the top level until you've narrowed in the frequency that you're interested in. And ultimately, you'll find the leak that way quicker and faster than if you were just try to hunt around up and down with the filter. So that's probably the best example. The nice thing about it, and I've put this in the hands of several different people, including a couple of my kids, and they were able to find a compressed air leak that I have on my compressor very quickly and very easily, just by walking through that process. So I hope that answers your question, Mike. If you want to see it in action, I guess the best thing to do is contact ITM and find a way to they'll help you out with that.
Definitely. And that's actually a great reminder for any who do have any questions about availability, pricing, if we have it available for rent, demonstrations, anything along those types of realms. I invite you to email us at info or information@itm.com. One of our sales staff will get to that email and be able to respond directly to you. We have a bunch of outside sales reps who are available to come to you with a demonstration, etc. So again, info@itm.com. Next question we have is from Tim. Have you had any success in detecting propane leaks with these units, and do you have any examples if so?
The answer is yes. Propane and natural gas are similar. The device doesn't really care what gas is leaking. There is some discussion to be had around the density of the gas and the pressure, because those two combine to give us the ability to hear it. But I do know that we've had some folks already find propane leaks, argon, natural gas, all kinds of LEL type concern, flammable gases, I guess is a good way to word it. So it shouldn't be too much of a problem. As for actual picture applications, I'd have to dig around. I could make that information available back to Chris if I can find an application picture, if that satisfies your needs to see it in action.
Perfect. So Tim, just for that, if you're interested in getting a follow-up email with maybe images or some specific examples, please chat your contact info. We'll grab it and we'll follow up with Ken and yourself at a later date. Next question we have, I apologize in advance if I butcher your name, but Fouad, thanks us for the presentation. Thanks you, Ken, for the presentation. And asks, can this device detect a leak behind drywall, or does the pipe need to be visible?
So we need to have line of sight. The leak or the sound that comes from it is ultrasonic, and high frequency has a tendency, as we talked in here, to bounce around. So it will bounce off the back of the drywall and not get through that material at all. So we need to be able to see as direct line of sight as possible, or maybe a place where there might be a reflection, but line of sight is what we'll need to confirm an actual leak.
Perfect. And our next question was directly correlated to that. So Lauren, I do hope that answers your question as well. As a friendly reminder, if you do have any questions, still have plenty of time to get to any and all that you have. Use the chat feature. The next question that we have, let's see. So this has come up, I know it myself personally, but for when detecting a leak or anything that, do you recommend that customers still use a physical tag, or can the images be sent to them through, example, Fluke Connect, in order to kind of trace and track the repairs that are needed?
So the ii900 and the ii910 both have a USB-C connection, and you use that with the cable that comes with it to connect to your USB port on your computer. And when you make that connection, it shows up in your Windows folder as like a USB jump drive. You drive in through the actual file folders and find the images or videos, and that's how you get access to the items that you've saved on the ii910 or ii900. Once they're there, you can easily copy, paste, put them in file folders, or you can, I know sometimes we just right-click on it and share it by email right from our Windows PC, or even a Mac for that matter. And we can share those from that. It doesn't work directly with Fluke Connect, so there's no wireless connectivity. For those people that don't know what Fluke Connect is, we have a bunch of tools that are Bluetooth enabled and free apps available for phones for both Android and Apple that allow us to communicate to these apps, these tool test equipment remotely. An example might be a current clamp in a cabinet. We can turn on the Bluetooth, communicate with the cabinet closed, and be able to read the values from our current clamp remotely. And then once that information is in our phone, we can share it from there. But the ii910 and the ii900 don't have the Bluetooth Fluke Connect capability. We still would just grab it and then bring it to a computer and then share it from a computer to whoever needs to see those images.
Perfect. Another question came in, does air temperature affect the measurement at all?
The air temperature doesn't necessarily affect it. The unit itself has some temperature and humidity limitations. Let me just see if I can go back to the slide, because I think it was on that slide. It's back quite a ways now with the application stuff. Here we go. So if you notice there's the operating temperature from -10 to 45 degrees C. A part of that is that it has to be from 10% to 95% non-condensing humidity. So that has more to do with the functional operation of the electronics and the microphones and the actual display, the touch display. That type of information would be our limit for where we would say that everything that we do, we are fully functional and fully capable to do. It doesn't mean I can't take it to -20 or -30 for that matter. I just wouldn't want to leave it in that environment or start it in that environment if it's been sitting in a truck overnight. But the actual microphones, I believe they're still functioning to -10. I mean, that's a part of the specification. I think that answers your question. If not, just let me know. I'm here.
Definitely. All right, next question comes in from Paul. Has the 900 and the 910 been used to detect liquid leaks?
We had that question asked very early in the ii910. Liquid leaks are a little bit more obvious than air. If it's an oil leak or a water leak, usually it's spraying and you can see it. I wouldn't suggest that you would use our device to look at that. I don't think it generates the same high frequency events that we would need to be able to have the ii910 find it. And you would most likely be able to see it in other ways, either visually or in a pressure drop. If you had a pressure system, you'd be able to know to start looking. There is something to be said for finding leaks using a thermal imager on liquids. And if you wanted to continue that discussion, I suggest you give ITM a call, or maybe they can reach out to me rather than to have a deeper discussion off topic here.
Absolutely. So another friendly reminder, for questions like that, if you want any follow-up to a very specific application question that you want to be answered, need to get answered, please email info@itm.com. Our sales reps will get back to you with all the answers that you need. If we do need to bring Ken in as a follow-up or just for a product matter expert, we can do so privately and directly. Another question in from Rodney. Have you had the opportunity to see if this will detect harmonics in a motor application or a motor drive application?
We can definitely hear when there's harmonics. That's a part of understanding how they work. You can hear fifth and sevenths. I'm not sure. I haven't tried that application myself. Again, we can hear them, but the higher frequencies, even at the 50th harmonic, which usually is diminished by that point in time, it's not high enough to be concerned about looking at it with an ultrasonic type detector. And so I wouldn't suggest that this is the tool for that. We have plenty of power quality tools that are, for the most part, very quick and easy to use. and even the information that we give you is pretty simplistic, or as detailed as you need to be. So have a discussion with the folks at ITM about that application, and they'll be able to narrow down from the different products that we have available, probably something that will work better than the ii910 or ii900 for harmonic detection or measurement.
Perfect. We do have another question in. I know that I personally get this quite often when discussing this type of application. And I know we did cover it with the mysterious customer with the red labeled cans. But can this device be operated in an excessively noisy environment, high pressure burner area, etc., something like that?
Yep. Yeah, there shouldn't be too much problems. Again, the microphones themselves are their ability to, gather the full spectrum, and then also software-wise be able to tune in. There hasn't been any problem that I've run across. I've been in some pretty noisy environments, so places where you would need to use earplugs and headphones, we can still use the ii910 and ii900 to see a leak. So I would highly suggest that if you're in a unique application and you would want to confirm, I'm sure that ITM will help you figure out a way to confirm before you buy.
Definitely, definitely. Another question that we have is there a minimum pressure that needs to be attained, or depending on what you're measuring, in order to detect a leak?
So it's a great question. We've had an internal competition before the ii910 came out within the Fluke people to see how low a pressure we could see. And one particular sales guy in the US was claiming he could see a 4 psi pressure leak. I doubt it would get that low. The 3 to 15 psi application, that was at 15 psi. We could definitely easily see that, as we saw by the image. I think it comes down to a combination of pressure and the density of the gas, and creating the ultrasonic noise of that leak that we need to be able to find. We are very interested in seeing how far the ii910 can go, because if that other guy's claim is right that he could see 4 psi, then we'll be able to get even lower with the ii910, which opens a door for some other unique applications that we are really interested in seeing if we can manage. To answer your question, I believe I would, if I was forced to say a certain pressure, I would not want to personally go below 15 psi with the ii900. And again, with the claim as being twice as sensitive, maybe we would get down below 10 psi with the ii910. Again, if you have a specific application where there's a leak, or you want to try to confirm, get an ii910 in your hands from a demo or rental, and we'll be able to help you figure that out.
Perfect, thank you. Another reminder, we have a little over 10 minutes left for the presentation and the Q&A time. So please use the chat feature for any and all questions. If we don't get time to answer your question, we will take it offline and contact you directly. So feel free to berate us with as many questions as you can. Similar to a question that we addressed earlier about the frequency, this question came in being HVAC specific, in order to how go about isolating an HVAC duct leak given the mechanical noises and the vibrations.
Yeah, so if you're talking about big air handling systems, similar to that coal plant, cement plant ducts thing that we see, it's actually pretty easy to just go in, start off with a wide band above your audible, narrow it down, and find vacuum leaks or even air pressure leaks if it's on the positive side of the pressure. They're pretty easy to see and find. It's one of the applications actually that the ii900 excels at, I would suggest.
Perfect. Looks like we have another follow-up question from Paul. Has it been used to detect leaks during an ASME B31 sensitive leak check?
Ooh, I'd have to go pull up Google to find out what that test is. I'm sorry, I don't know. If we can take that offline, I'd be more than happy to dig into it.
Perfect. So Paul, much like I mentioned to, I believe it was Tim earlier, please send us your contact info through the chat so we can contact you directly, and we'll take this privately offline. And one final reminder, please use the chat feature. Take advantage of having Ken connected here while we still have him for another 10 minutes or so. Any and all questions are welcomed and wanted at this point. Would the 900 or the 910 work to detect small leaks around windows?
So that application picture on the space station had a very unique factor involved at the fact that they were in outer space or in a vacuum. So the space station was pressurized and it was venting to the vacuum. So they were actually finding a leak, or a vacuum leak, if you want to call it, was really what they were looking for on that window. If you're talking about like a residential house, I would suggest that there's not enough pressure difference to be able to see it. You may have a blower door and you might be able to see something along those lines, but if I'm not mistaken, the pressures are quite low on a blower door application. If you have a clean room application where you're creating negative pressure, there might be a chance to see a leak. If you were looking for like energy efficiency around windows, probably one of the best ways to approach that would be with a thermal imager. It's very well documented. As long as you have about a 10 degrees Celsius temperature differential, you'll be able to use a thermal imager with pretty good sensitivity. So you got to consider your thermal imager's performance capabilities, but they're very good at seeing these types of leaks. And again, only 10 degrees Celsius temperature difference in Canada, that's pretty easy to get a handle on.
Definitely. So one last call for questions. Please use the chat feature. And I did have, pardon me, I just have to go back to, oh yeah, so we have had a few questions come in about demos and availability. Again, I'll just remind everyone, pricing, availability, demos, rental, buying, anything of the like, you're welcome and you're invited to email info@itm.com or information@itm.com. And one of our sales staff will respond to you with all that type of information. We'll wait maybe 10 seconds to see if we have any last minute stragglers. If not, as a reminder, if you have any questions post-presentation, you can also use the info@itm.com. If follow-up with Ken is needed to answer your questions, we have absolutely no problem doing so. And so far, nothing has come in. So, Ken, I will thank you once again for the great presentation. Thank you for taking the time and spending with us to demonstrate and to bring us up to speed with the ii900, the ii910.
Yep, you're welcome, and thanks to everybody that attended. I know it's time out of your day, and we appreciate your attention as well.
Absolutely. So on behalf of ITM University, we thank you for attending today's webinar. We hope that you found it informative and helpful. ITM instruments are available to assist you in any way. Visit our website, itm.com, email us, info@itm.com. If you need anything, including our contact information, it can be found on the website. At the end of this webinar, we'll have a very short survey that we'd like for you to complete. Your feedback is imperative and great for us, so it assists us in improving our future webinars, as well as bring in some topics that you, the customer, are interested in hearing about. Don't forget that as a thank you for attending today's webinar, your name will be entered into a draw to win $100 for your next online order. The winner will be announced on our social media channels, so be sure to check us out there. Once again, thank you everyone for attending today. Ken, thank you very much. And I wish you all a great rest of your day.
Cheers.